We are going to talk today about the Poisson distribution. A Poisson probability distribution is used to determine the probability of a designated number of successes per unit time when the events or successes are independent and the average number of successes per unit of time remains constant. So, this is the most important two assumptions down here. When the events or successes are independent and the average number of successes per unit of time remains constant. So the probability of x number of successes is given by lambda to the power x e to the power minus lambda by x factorial, where probability of x number of successes is denoted by p bracket x and lambda is the average number of successes per unit time and x is the number of success. Let's jump into a call center case study. A police department receives an average of 5 calls per hour. Calculate the probability of receiving 2 calls in a randomly selected hour. So, lambda is the average number of success per unit time is equal to 5 calls per hour, x equal to number of successes equal to 2 calls per hour. Therefore, Px equal to 2 is 5 to the power 2 e to the power minus 5 by 2 factorial, that is 25 star e to the power minus 5 by 2. So, it comes out to be 0.08425. A very interesting case study, a football case study. Who would have thought that we could have applied Poisson distribution to a football case study? So, here again it is. Ugarte and colleagues report that the average number of goals in a World Cup soccer match is approximately 2.5 and the Poisson model is appropriate. Because the average event rate is 2.5 goals per match, lambda is equal to 2.5. The probability of k goals in a match is 2.5 to the power k e to the power minus 2.5 by k factorial. Therefore, P is equal to K is equal to 0 goals in a match is 2.5 to the power 0 e to the power minus 2.5 by 0 factorial is equal to e to the power minus 2.5 is equal to 0.082. The probability of one goal in a match is 2.5 into e to the power minus 2.5 by 1 factorial, that is 2.5 into e to the power minus 2.5 is equal to 2.205. P's probability of 2 goals in a match is 2.5 whole square e to the power minus 2.5 by 2 factorial, that is 6.25 into e to the power minus 2.5 by 2 equal to 0.257. So the acknowledgement is again from Wikipedia. The floods case study. On a particular river, overflow floods occur every 100 years on average. Calculate the probability of k 0, 1, 2, 3, 4, 5 or 6 overflow floods in a 100-year interval, assuming the Poisson model is appropriate. Because the average event rate is 1 overflow per 100 areas, lambda is equal to 1. Therefore, k is equal to 0 floods in 100 years, that is equal to 0.368. K is equal to 1 is 0.360. K is equal to 2, that is 0.184. This is also from Wikipedia. Hope you liked the lecture on Poisson distribution with the associated case studies. Thank you. Bye.